All right, if we're going to look at sp2 hybridization then, let's go back and look again at our unhybridized set. Remember, there's an s orbital that surrounds us like a big ball. The two red balloons here represent the shape, something like the shape of an unhybridized p orbital. The two blue balloons represent the shape of an unhybridized p orbital, and the yellow balloons represent the shape of an unhybridized p orbital. And that unhybridized s orbital surrounds us like a big ball. So in the sp2 hybridization, we're going to hybridize 3 of the 4 orbitals in the valence level. So this s orbital, these 3 p orbitals make up the valence level orbitals we're talking about here. And we're going to hybridize all but the red p orbital. So notice the p orbital here in the unhybridized set has 2 parts. Well, those 2 parts of this p orbital here still remain. So this p orbital is not hybridized. What we did hybridize was the yellow p orbitals, the 2 nodes of the yellow p orbital. That becomes a single hybridized orbital here. We hybridized the 2 blue balloons here, which represent a p orbital. So that became a single balloon shape. It's a hybridized sp2 orbital. And the s orbital, which we don't have a big round balloon for, that you can think of as being a green round balloon surrounding everything, that's the s orbital, is hybridized in this single green balloon here. That's the hybridized orbital. So our unhybridized orbital then is this p double balloon shape. The hybridized orbitals are the 3 balloons here, yellow, blue, and green. Okay? So with this sort of arrangement, then we could do what's called double bonding, where one of the orbitals, say this hybridized s orbital here, this p that became this hybridized sp2, can do that single bond in between 2 atoms, and the pi bond can take this p orbital and reach out above and below to connect to another atom. So a pi bond has what appears to be 2 parts, one running across the top, one running across the bottom. That's the pi bond. The sigma bond has what looks like 1 part, that cigar or wiener shape in the middle. And we might get something like this. So this would represent what an oxygen atom or oxygen molecule will look like, where we have 2 hybridized lone pair orbitals here. Lone pairs are in the blue and the green balloon shapes. So the hybridized orbitals have this shape. Lone pairs are there, so it looks like a hybridized orbital. But the p orbitals that we didn't hybridize, okay, one's coming up here and one below, and one coming up here and one below. The 2 nodes above and below reach out and stretch across the top and bottom and grab each other and overlap and share a 2 p orbitals to make a pi bond. So the red is 2 parts, the red balloons are 2 parts of the same orbital. A pi bond, those orbitals overlap and make a pi bond. So 2 parts of a pi bond. Okay? And you have a sigma bond here in the middle, which is an overlap of 2 hybridized orbitals. So we started out with this. This hybridized orbital reached out, made a sigma bond to another atom. These 2 p nodes of the same p orbital, reach out across the top and bottom and make that pi bond. P orbitals make a pi bond, top and bottom. You can think about this shape as kind of like a hot dog, where there's the wiener and these 2 parts of the buns. All right, so that's what oxygen looks like with 2 lone pairs out here on both ends. So an oxygen atom here, an oxygen atom here, 2 lone pairs on both. This would represent something like what we would call an ethene molecule, where what we have is a carbon here and a carbon here. Again, we have an sp2 hybridization. The sigma bonds here and here are formed from hybridized orbitals overlapping between the carbon here and a hydrogen up here. It might be something else. We could make another kind of molecule that wouldn't be hydrogen out here, but in this case, if we're going to call it ethene, then we have to assume this is hydrogen. So there's a sigma bond going to a hydrogen here, a sigma bond going to a hydrogen here, a sigma bond going between the 2 carbons, and a pi bond coming across the top. So this bond here came from a hybridized orbital. This bond here came from a hybridized orbital on that central carbon. This sigma bond here came from a hybridized orbital on this carbon. And this pi bond going top and bottom here came from an unhybridized p orbital on this carbon and this one stretching across the top and bottom. So that is a representation of how sp2 hybridization results in double bonding. All right, so then if we have triple bonding, then we're going to have a whole different set of hybridization called sp. Let's pull these out of the way a minute.